Okay, 24 says to find the inverse of the function y equals x squared plus 4 minus 1. And I'm actually just going to write the minus 1 there because it looks like it fell off. Okay, so this one is tricky. I'll admit that the first time through I felt like I should see a choice here that says something like that. It's not invertible. Because so I have issues with this question. But anyway, let's work through it, what I know that they must mean. So, of course, what does it mean for a function to be invertible? A function is invertible if so it has to be a function, of course, you're calling it a function, but it also has to be a one-to-one function if you're expecting the inverse to be a function, right? So so take some cubic or something like that. This passes both the vertical line test, of course, because it's a function, and the horizontal line test because it's a one-to-one function. Now, if I take this one-to-one function and I find its inverse, right, so which is graphically or visually going to be a reflection of the line y equals x, I'm going to get something that is still a function, right? This still passes the vertical line test. So when we ask if a function is invertible or not, that's usually what we refer to. Now, what they're doing is they're saying, okay, well, maybe I'm starting with something that's not invertible, right? They're starting with a quadratic. I'm going to just draw a random parabola. I still can take its inverse in the sense that I still can actually compute what happens if I switch the role of x and y, in other words, reflecting over the line y equals x. So I did this sort of messy, but so of course the result will not be a function. But ultimately, that's what they're looking for us to do, is to just take the inverse. In other words, switch the roles of y and x and find the function that is like the reflection over the line y equals x. Now, it's not going to be a true reflection actually here, because when square roots get involved, we would technically need the plus or minus there, which they're not accounting for. So I have more issues with this problem than I can really express. But and do know that the people who wrote this exam aren't necessarily the same people who are writing the praxis. So this is just to give you the right feel of the right concept. So if you understand the idea of invertible, you understand how to find an inverse, you understand all these ideas, the fact that here that there was no choice that said it's not invertible sort of speaks to the fact that you know what you must have to do. So what we're going to do is we are going to solve for like this, right? I'm going to try to solve for y. So how do I do this? So because of the way it's written, what I have to do is I have to try to complete the square. So I'm going to bring that 1 back over to the other side. And I want to add the number that will make this a perfect square factor. So I'm going to want to add 4. If I add 4 to the right, I have to add 4 to the left. So I get x plus 5 is equal to y plus 2 quantity squared. So solving for x, I get x equals y plus 2 quantity squared minus 5. Actually, I want to leave, I'm going to leave that over on the other side. X plus 5 is equal to y plus 2 quantity squared, because I'm solving for y, not x, obviously. Sorry. Okay, so I'm going to take the square root of both sides. Here, what I would like to do, is what I wish I could see in this problem, is I want to see a plus or minus the square root of x plus 5 here, and then subtract plus or minus x plus square root of x plus 5 minus 2. So if I graphed this in my graphing calculator as two functions, one with the positive, one with the minus, then I would get both halves of the sideways parabola. Notice that this isn't a choice, though. So the thing they must mean, and again, I don't even like this because of how they wrote it, but the square root of x plus 5 minus 2 is what they're looking for. So there you go. I don't love the problem, but that's what it is.